Thin scan backwell inspection with LPS 05 quarter. Part 1. Equipment. Thank you for using low-profile quarter LPS 05, produced by SIUI. In this application, we use the thin scan flow detector and the low-profile quarter LPS 05 to inspect a pipe with diameter 108 mm and thickness 7.5 mm. Part 2. Test widget for small diameter pipe weld. Press application to enter application interface. Press small pipe to enter test widget for small diameter pipe weld. Press Next. Click Add in the workpiece management interface and choose V-Weld. Enter related parameter based on pipe. Press Finish. Input new workpiece name and then press OK. Press Next to enter selection of probes and wefts. Unselect probe and then press OK. Adjust wet selection. Press Next to enter scan type setup. Adjust type to setter. Adjust echo time to T-wave. Press Next to enter focal loss setup. Adjust start angle to 45 degree. End angle to 75 degree. Focus to 15. Adjust distance ET to ensure beam coverage simulation can cover weld inspection area. Press Next to enter display mode select interface. Adjust display 1 to A plus B plus C. Press Finish and the screen prompts update simulation scan parameter to system. Press Yes. Part 3. Probe and wedge assembly. Connect the copper sleeve with the pipe divider and insert the pipe divider to the probe irrigation column. Then insert the copper sleeve in the irrigation column firmly to fix the pipe divider. Apply some couplant on the probe and wedge matching surface, and assemble the probe on the wedge with a cross screwdriver. Part 4. Calibration. Velocity calibration. Put the probe on the pipe weld calibration block. Press Velocity calibration to enter Velocity calibration interface. Adjust reference 1 to 25 mm. Adjust reference 2 to 50 mm. Gain mode to style pass. Press Next. Move the probe back and forth to enable reference point 1 achieve the maximum echo amplitude. Press Record, and to bring a scan echo of reference point 2 in the center of gate. Move the probe back and forth to enable reference point 2 achieve the maximum echo amplitude. Press Record, and the screen prompts Calibration Finish. Press Finish and the screen prompt, do you want to enter the next calibration delay calibration? Select Yes to go to delay calibration. Delay calibration. Set reference point to 50 mm. Reference error to 5%. Gain mode to style pass. Press Next. Move the probe back and forth to enable each scan line to achieve the maximum echo amplitude. Press Calibrate. If the calibration result is correct, the red position envelope line should be among the yellow dotted lines. Select Finish to finish the calibration, and the screen prompts, do you want to enter the next calibration sensitivity calibration? Select Yes to go to the sensitivity calibration. Sensitivity calibration. Adjust reference amplitude to 80%. Reference error to 5%. Gain mode to style pass. Press Next. Move the probe back and forth to make each scan line reach the maximum echo amplitude. Press Calibrate to finish sensitivity calibration. If the calibration result is correct, the green amplitude envelope should fall between the yellow dotted lines. Press Finish and the screen prompts, do you want to enter the next calibration TCG calibration? Select Yes to go to TCG calibration. TCG calibration. Adjust reference amplitude to 80% and reference error to 5%. Gain mode to depth. Press Next. Move the probe back and forth to make each scan line reach the maximum echo amplitude. Press Record, and the record menu displays 1-1. Move the probe back and forth to reproduce echo amplitude envelope of each scan line. If the calibration result is correct, the green amplitude envelope line should fall between the yellow dotted lines. Press Next point and the record menu displays 1-2, and then finish the calibration of reference point 2 by referring to reference point 1. Adjust curve number to 3, curve 1 to -24 dB, curve 2 to -18 dB, curve 3 to -12 dB. Press Finish. Press Advanced Scan to start horizontal zero calibration. Press Gate. Adjust steps to 70 mm. A-line to 16. Put the probe on the calibration block and find 10 mm depth side drill hole. Stabilize the probe position and measure the horizontal distance L1 between the probe flank and the test block edge, and L2 between side drill hole and test block edge. L1 minus L2 equals D, probe flank and side drill hole distance. Adjust horizontal 0 to make sure RA minus 1 equals D. ER is the distance between probe flank and the valve center. Part 5. Crawler Assembly. Use the head screwdriver to loosen the screw on the LPS 05 crawler for about half turn. Rotate the probe connection and the encoder frame to expose the probe arm, so that it may travel outward. Use the head screwdriver to loosen the fixing screw on the probe holder for about half turn. Hold the front of the probe arm to clamp the wedge. Adjust the wedge position, aligning the wedge center with the probe connecting link center. Tighten the screw to fix the wedge. After assembly, ensure that the wedge can be rotated freely without shaking. Assemble the LPS 05 scanning link on the pipe and make sure the 4 welds are in contact with the pipe surface. Press down the probe holder to enable the 2 bolts beneath to contact the pipe surface, and then tighten the screws. We start cleaning up cables. Put the probe cable and pipe divider through the cable piece. Use the screw to fix cable piece on the crawler. Put the encoder cable, pipe divider and probe cable through the ferrule intern, and put the ferrule through the braided tube. Please reserve a proper length to avoid the probe and the encoder being constrained and cannot rebound freely. Use a hexagonal screw to fix the ferrule on the light clamp. Use a ruler to measure the distance between the probe flank and the valve center, ensuring it's consistent with the ER. Part 6. Advanced Scan. Press Advanced Scan. Press Setup. Adjust scan mode to encoder negative. Scan step to 0.49 mm. Press Control. Adjust CD selection to On. Adjust CD rectangle position to cover the first and second inspection area of the weld. Press the manual irrigation device and water will flow out. Rotate the crawler clockwise along the circumferential valves of the pipe to collect phase array inspection data. The screen will display the image and the flow. Press N to store data into the system. Input file name and then press OK. The screen prompts Save. Part 7. Super-up software operation. Click File and select the file transferred from the system to the computer. Right-click the B scan and press CD selection. Adjust CD sample rectangle to cover well first and second inspection area. Right-click the C-scan image and select Measure and then select Measure line. Zoom the image. Use the red and blue reference line to record the floor. Click Measure Rectangle, and the measure result will be displayed in the measure view. The length of the floor is 40.82 mm. Move one reference line to record the radius point of the floor, which means to record the highest echo. Right-click B-scan and select Measure, and then select Measure line. Zoom the image. Use the red and blue reference line to record the floor. Click Measure Rectangle, and the measurement result will be displayed in the measure view. The height of the floor is 3.16 mm. Adjust A scan line to the highest echo. In A scan image, move the A gate to record the highest echo. Click Measure A with gate A. The depth of the floor is 5.64 mm. In Super-up software, you can mark the image when you analyze it. Click Remark and select Mark. Click Remark and select Ring. Click Report and select Report Now to generate a report.